Hey guys, today we are going to talk about parallel and perpendicular lines. Okay? So first of all, parallel lines. We've talked many times about this throughout the years, I'm sure. These are lines that run in the same direction. And never touch. That's a U. That's a weird looking U. Okay. So they run in the same direction and never touch. The fun thing about parallel lines is that the slopes are going to be equal. So the slopes of parallel lines are the same. All right? Parallel lines will never intersect with each other. So for instance, over here, we're going to prove that they are parallel. So there they are. So we can write out the equations of the line just by saying, well, we've got 2 points. We'll pick the point right there on this one and there on this one. Okay. So our y-intercept, or our b, will be 1 because that's where it crosses the y-axis right there. The slope, well, we've got 2 points, so we count. We go 1, 2, 3, and 1, 2. So the slope, it goes down 3 and over 2. So there's your first one. So we've got y equals -3/2 x plus 1. Okay, and the second line here, we'll do the exact same thing. There's 1 point on the y-axis. There's another perfect point, so it'll be nice and easy to count. Same thing, we've got b is equal to 7, and our slope this time, again, 1, 2, 3, and over 2. So it is again -3 over 2. So now, moving forward, this will be enough information to show that these two lines are parallel. All right? Okay, so I guess I didn't have to do the whole equation, but the point is just that when you've got two lines like this, if I give you two equations, you just look at the number in front of the x, and if the number in front of the x is equal, then the two lines are parallel. Okay, the b and the other b are not equal. That's fine. That has nothing to do with it. That just tells you how far up it's been shifted. Okay. All right, perpendicular lines are lines that intersect at a 90-degree angle. All right, so two lines that are perpendicular intersect at a 90-degree angle, and so the slopes of these lines, and this is something that you probably haven't heard before, but they are negative reciprocals, we call them. Negative reciprocals. Okay. And if you haven't heard of that, and that's okay, because there'd be no reason for you to, these are two numbers whose product is -1. So for instance, if 2 is the original number, then -1/2 is its reciprocal. Okay. Another way to remember this, and probably an easier way to remember this, is if you have a number, if it's a whole number, okay, so let's say it's a, whatever a is, it's just a whole number, the reciprocal, or the negative reciprocal, well, first of all, the reciprocal part means that it's 1 over a, and these are negative reciprocals, so it's made negative. Okay? If you get a fraction, as we often do with slopes, what you'll do is you will just flip that fraction upside down and then make it negative. Okay? So you flip your fraction. If it's not a fraction, you're going to just change it to 1 over. Okay, and then you change the sign from positive to negative, or negative to positive. Okay, I'll give you one last example here. I'll say if I give you -3 over 2, the negative reciprocal. So first of all, you flip the fraction, so it becomes 2 over 3, and you change the sign. This one was negative though, so this one will be positive. All right, and that's it. Okay, so we're going to show that these two lines over here are indeed perpendicular. So I've given you 2 points on each, so we're going to find the slopes. Okay, so hold on. Let me write the slopes down over here so that I can see it while I'm doing it. -3 2, and what was the other one? 1, negative 2. All right, so here we go. We're going to find the slope. And to do this, we can use our slope formula, which was y2 minus y1 over x2 minus x1. So we'll go through and we'll label this x, y, x, y. This is point 1, and this is point 2. And then we just go through and use our formula. Okay, so we have 2 minus 2 over, that can't be right. That can't be right. That won't work. Oh, it was negative 2 here. Oh, that's a negative there. That's why I got confused. Okay, so that changes it to 2 plus 2 because it was negative. And then we have 1 minus negative 3 will be plus 3. So we get 4 over 4, which is just equal to 1. Okay, that shouldn't be right though. What have I done? What have I done? Oh, I see what I did. I got my 2's backwards, so that should have been negative 2. Oh my goodness. And that's not working. There we go. All right, so let's try. And okay, I didn't mean to erase that much. Let's just do it like this. This should have been a minus. That's a minus. So negative 2 minus 2, so that's a negative 4, which gives us a negative 1. All right. Nice thing about this stuff is when you do make mistakes, like I periodically do, we can check it because you look at this red line here and you know it's a negative slope because it's going down. So when I did it and I got a positive answer, I knew that I made a mistake there. Okay. All right. So let's do the second line. We got negative 1, negative 2. Try not to mess that up this time. And we've got 3, 2. All right. So here we go. Same thing. We'll go x, y, point 1, point 2. All right, and then I say m equals y2 minus y1 over x2 minus x1. All right, so we have 2 minus negative 2, so I'm going to call it plus 2. Hopefully I did it right this time. And then I've got 3 minus negative 1, so I've got plus 1. All right, so that's going to give me 4 over 4. And this one is indeed equal to 1. Okay, so if we look, the two slopes that we have, we've got negative 1. It's hard to see that that's a negative 1. Let's make it very clear. Negative 1. There we go. So we had negative 1, we had positive 1. Negative 1 is equal to the negative reciprocal of positive 1. Okay? If you flip it, and you make it negative, you would get the other one. All right, so there we go. All right, so let's take a look at this. If we're told we have to find the negative reciprocal, so we're going to find the reciprocal of negative 6. Okay, negative reciprocal. So you're going to divide 1 by the given number. Okay, so it just means that we're going to take that 6 and you're going to put 1 over that 6 and multiply the answer by negative 1 because it should be, well, okay, so it was negative 6 and then we changed the sign. Whatever, this is a confusing way to do it. Don't do it like this, okay? It's just 1 over 6, okay? Take the number, flip it, okay? So it becomes 1 over 6 and then change it from a positive or from a negative to a positive, okay? If you want to check your answer, you just do 1/6, which was our new answer. You multiply by the negative 6, and hopefully that will give us negative 1, which it does, so then we know we've done it correctly. All right, so let's do a couple examples here. So I'm giving you 2 lines, and we're going to decide if they're parallel, perpendicular, or neither. Now, the nice thing is, this one is already done in y equals mx plus b. If they're in this slope y-intercept form, it's very easy because we can just look at that and say that the slope is 3 because the slope is whatever's in front of the x. Same with this one, m is equal to 6 over 2, which of course 6 divided by 2 is just equal to 3. So I have 3 for both, so therefore this one's parallel. All right. This guy over here, our slope of our first one, again, it's just whatever's in front of the x, so it's -3. Whatever's in front of the x on this one, so it's going to be 1/3. And if the negative reciprocal of 3 is of -3 is positive 1/3, okay? So we know that these are perpendicular. All right, there we go. So let's make it a little harder. So this time I'm going to, or you're going to write the equation of 2 parallel and 2 perpendicular lines for each. So this one has a slope equal to -3/4. So to do parallel lines, we'll do parallel. Doesn't matter what you do, as long as that number in front of the x is the same. So I could have y equals -3/4 x, and then I just have to change the +5 to something else. Let's change it to +2. We'll do another one. And just for fun, let's say -1000. Okay? It doesn't matter what this number is. As long as this number is equal, they are all parallel lines. Okay? Let's do some perpendicular lines. So what we need for this is we need to say, okay, so the original slope was -3/4. So if we're going to find the negative reciprocal, you're going to flip the fraction to 4/3. It was negative, so it becomes positive. So I can do any equation of a line that has a slope 4/3, and that will be perpendicular. So I could do +1. I could do y equals 4/3 x minus, let's go with 1,000 again. Okay? It doesn't matter, again, what this number is or what this number is. All that matters is that this number is this number, okay? So as long as that number is the negative reciprocal, we're going to be okay. Now, if I give you a number or an equation in standard form, you're going to do exactly the same thing. However, we have to figure out the slope. And the easiest way to find the slope, if we're written in standard form, is to just convert it to slope y-intercept form. So I'm gonna move these guys, okay? And we're left with -6y equals, the 3x becomes -3x, the -24 becomes +24, and then I'm just going to divide by -6. And so I get y equals 1/2 x plus, minus, and 24 divided by 6 is 4. Okay? So what's important here is this guy right here. So for parallel, anything with 1/2 as the slope, so I could have y equals 1/2 x minus 7. I could have 1/2 x, and we might as well keep up our theme and say minus 1,000. Perpendicular, y equals, now we need to know the negative reciprocal of the slope, so 1/2, I'm not sure why this is so thick, okay, the negative reciprocal, you can hardly even see that color, whatever, you flip it, 1/2 flipped becomes 2/1, which we're just going to write as 2, and it was positive, so we're going to write it as negative, okay, so I'm going to have -2x, and it doesn't matter what comes next. I'm going to leave it because I don't even have to have a y-intercept. It could be +0, which is just nothing. Or I could have -2x minus 1,000. All of those are fine. Okay? So we are going to take up the final example in tomorrow's class. So until next time, go Sabres.